Hi, I'm Shijo Joy, and I'm a Senior Product Manager on the Azure Stack HCI team. Today, as part of the Azure Arc Enable Infrastructure Technical Series, I'm excited to talk to you about the new integration that we have introduced of Azure Site Recovery with Azure Stack HCI. Let's get right to it then. Here is the agenda that I plan to cover as part of this session. In studies which have been conducted in the past, data recovery has been called out as the top technical challenge of unplanned downtime. Furthermore, the average downtime frequency is approximately once every quarter, with the downtime lasting 95 minutes on an average. There are the direct costs, often measured in lost sales during the time period of the outage. Beyond the direct costs are the indirect costs, such as the impact to overall brand, which can be both greater and further reaching. To mitigate this unplanned downtime, there is a need for organizations to have a comprehensive business continuity and disaster recovery strategy. A comprehensive BCDR plan requires all three solutions, that is disaster recovery, backup, and high availability. The key is to decide which workloads require which solution. As an organization, you need to adopt a BCDR strategy that keeps your data safe and your apps and workloads online when planned and unplanned outages occur. When we specifically talk about Azure Stack HCI, where it is residing in your environment, it is imperative that there is a way for you to ensure that the critical workloads that are running on your HCI cluster are accessible at the time of an outage. Azure Site Recovery helps ensure business continuity by keeping business applications and workloads running during outages. Azure Site Recovery replicates workloads running on physical and virtual machines from a primary site to a secondary location. When an outage occurs at your primary site, you fail over to a secondary location and access the applications from there. And after the primary location is running again, you can fail back to it. So let's deep dive into Azure Site Recovery. Azure Site Recovery is a PaaS-based service which leverages Azure Cloud to seamlessly scale as per your needs. Leveraging Azure as a recovery data center eliminates the need of setting up and maintaining a recovery data center, providing you a significant cost saving. Customizable recovery plans with capabilities like boot order and script support, along with really good RPO and RTO with point-in-time recovery of up to 72 hours, provides an enterprise-grade application recovery. Azure Site Recovery offers no-impact DR drill and centralized monitoring and reporting, which allows you to attain disaster recovery evidences and meet your compliance needs. ASR offers you to replicate your workloads to your own subscription, ensuring business data remains in your own security boundary. On top of this, with the on-wire encryption, encryption at the storage layer, and Azure Disk encryptions, you get enhanced security for your critical workloads. Features like RBAC and Azure AD authentication allows you to scope the access to the DR configuration and environment. ASR ensures that a copy of the source disk is maintained in the target region by performing continuous replication and maintains snapshots that ensure a low RPO. At failover, new virtual machines can be created and replicated target disks can be simply attached to these virtual machines, ensuring faster restoration of services. As of today, ASR is supported on Azure Stack HCI. So you can deploy your ASR agents on the HCI nodes and have the VMs replicate over to Azure. It uses the Hyper-V to Azure tech stack, but there are issues which a lot of customers are facing with the existing model. So we have listened to the voice of the customer and hence this feature. Today, these ASR agents can be installed through either Windows Admin Center or directly through the Recovery Services Vault. In case of both these deployment models, you need to constantly switch between the Azure portal and on-premises to install the agent. But that's not the only problem. In case of Windows Admin Center, the deployment of the agents to each of the nodes has not been consistent, and that's feedback that we have heard. For example, in the case of a 4-node HCI cluster, we have seen issues where the agent sometimes gets deployed on 2 or 3 of the HCI nodes. There is, of course, the alternative where you can use the Recovery Services Vault to deploy the agents, but that would require you to go to each of the HCI nodes manually to install the ASR agent, which of course is a pain, especially when the number of the HCI nodes increases. So that's some context behind why we wanted to simplify the entire agent deployment process, and hence the scenario. The idea is to have a single-click experience for customers to install the agents on each of the nodes of the HCI cluster. And additionally, we want to leverage the goodness of Arc and have the agents installed on each of these nodes as an Arc extension. This would also mean that for any new node added to the HCI cluster, the extension would be installed on the node automatically by virtue of it being an Arc extension. Let's now unravel how things work behind the scenes. The user first navigates to the HCI resource within the Azure portal. And here they would see the new menu item that we have built. They'd have to configure the vault, the Hyper-V site, and the replication policy, and select the Prepare Infrastructure button. Once they do that, the portal will create a key or a certificate and will submit it along with the necessary parameters, including the expiry time of the certificate at the time of installation. This information will then be sent over to the HCI service, which in turn will pass this over to the Hybrid Compute RP. The Hybrid Compute RP will then initiate the installation of the extension. As part of the installation of the extension will get the certificate and the absolute time so that it can understand if the certificate has expired or not. If the certificate hasn't expired, then it will write it to a file and launch the installation. If the certificate has expired, the plan is for each node to wait for a random amount of time and then use the cluster managed identity to fetch a new certificate. We are picking the expiry time to prevent contention between two nodes which are getting connected at the same time and trying to install the extension at the same time. We are also waiting for a random amount of time to prevent both the nodes from requesting for the certificate at the same time, in which case the latest certificate will take precedence and the older certificate will be void. Here is a sneak peek into how we have enabled this experience right from the HCI resource within the Azure portal. As you can see, we have enabled the vault creation, the Hyper-V site creation, and the replication policy creation within a single pane. Let's now see this in action. As part of the demo, I have a 2-node cluster which is created named HCI cluster. Now within the HCI cluster resource, when you click on Overview, you will see the Capabilities tab, which will come up at the bottom. Clicking on the Capabilities tab will show you the various features that can be enabled on the HCI cluster. You will now be able to see the Disaster Recovery Capability tile, which will show you the status. And here we can see the status as not configured. Clicking on it will take you to the Disaster Recovery Blade, which is a new left menu item which we have introduced that's in public preview. Within this blade, you will see a 3-card layout which is consistent with what we have on ASR today. Clicking on the first tile to protect VM workloads will open up another two-tile layout, where step 1 is to prepare infrastructure and step 2 is to enable replication. This feature that we have built to deploy the ASR agent as an Arc extension primarily involves changes to the prepare infrastructure step. And here you can see the status shows up as infrastructure not prepared. When you click on this, you will see a new blade where first you have to either select an existing vault or create a new vault. Clicking on Create a New Vault will open up the vault creation blade, which is the same experience if you would create a vault from the Azure Site Recovery page. For the purposes of this demo, I will give it a name and leave the defaults as is. Creation of the vault will take a few seconds. Once the status shows up as created successfully, I then have to create a Hyper-V site, which again will take a few seconds to create. Once the Hyper-V site is created as well, I then have to configure the replication policy, which defines how I would like the virtual machines on my HCI cluster to replicate to Azure. Once that is done, I can then click on Prepare Infrastructure. Once you click on Prepare Infrastructure, it will then first assign the required permissions to the vault and then install the ASR extension, following which the replication policy which was created in the previous step will be associated with the Hyper-V site. You will see the status reflected within the tile. An important point to note here is that even if one of the nodes of the HCI cluster is connected and the remaining are disconnected, we will allow you to proceed with preparing the infrastructure because the ASR extension will be installed on the other disconnected nodes when they do get connected eventually. This is, of course, leveraging the goodness of Arc. As you can see, the status now comes up as infrastructure prepared successfully. You can verify the extension installation status by clicking on the extensions item on the left navigation pane. As you can see, the ASR extension has been installed on both the nodes of the cluster successfully. Now, once the ASR extension has been installed, the next step is to replicate the VMs. So if I go back to the disaster recovery left menu item, I can click on Enable Replication, which will redirect me to the vault, from where I can go about enabling the replication. Here, I'll have to select Replicate and specify Hyper-V VMs to Azure. Similarly, if I go back to my HCI resource, I can click on Monitor Recovery Readiness and it will redirect me to the vault, where I can then click on the Site Recovery tab to view the VM replication status. Finally, within the HCI resource again, I can click on Recover Workloads, which will take me to the vault again, where I can then fail over the VMs from HCI to Azure. That concludes my demo. So now summarizing what was discussed, the new enhanced agent deployment method alleviates the pain of agent deployment by deploying the ASR agent as an Arc extension. Thus, we are leveraging the Arc channel and with it, the goodness of Arc. When a new node is added to the cluster, which already has the ASR extension deployed, there is no manual intervention needed. The extension will automatically be installed on the newly added node. You can also enable automatic updates of the Arc extension, which reduces the administrative overhead. With this new agent deployment method, the intent to install the extension is at the cluster level. So there is no need to manually have the agent installed on every node of the cluster. Finally, VMs which are created via the Arc resource bridge, where Arc is the control plane, is a scenario which we are looking to address soon. Here are some resources that will help you get started. In addition to the scenario which I covered today, you can view the public documentation that talks about how managed identity gets enabled, which is a prerequisite for this feature. That's it from me. Thank you for taking time out to listen in on the session. It would be great if you could test out the feature, and I'd be very interested to hear your feedback. Thank you.